We are recording today's proceedings with the express intent of posting them on our webpage after the fact. I'll let that guide what you say and do this hour. If you wouldn't like to be seen on camera, please go ahead and turn your camera off. That's just fine. But it's a courtesy to all if you wouldn't mind renaming yourself with your name and institutional affiliation, if you would please. Help us all know who we are. Today, we're joined by a very special guest. Fred Cain has been an innovative technology advocate for over 35 years. He has a unique mix of business development, engineering, and project deployment experience. Over the course of his career, he's been recognized for outstanding performance in the development of customer relationships and for deploying complex technology solutions. He has a proven ability to drive results by building customer confidence and partner loyalty. He's been 10 years with a manufacturer, 7 years as a consultant, 15 years as system integrator, and 5 years in rental and staging. So welcome to this hour, Fred Cain. Thanks for coming.
Thank you very much. Thanks for having me. So if I could share my screen, I'll jump right in. And I will mute my camera for bandwidth purposes. I'm working from home today. If I can. So again, thank you for having me. I really appreciate the opportunity to present today. I'm going to start off by giving you a few slides about our company. I just want to give you an idea of who we are and how we fit in the marketplace. We're a Chinese company based in Shenzhen, China. For those of you who don't know, Shenzhen is much like the Silicon Valley of China. Many tech companies are headquartered there. Our factory is about 45 minutes outside of town in Weizhou. That's where we have our manufacturing facilities, as well as some dormitories, things like that. We own this entire plot of land that we're showing here, and so we have plenty of room to expand as our company continues to grow. We're a 22-year-old company, founded by 3 friends, and those 3 folks still run the company today. We have been the #1 exporter of LED from China to the rest of the world 13 years in a row. You can see that number is remaining high as a rebound from the COVID year. That number we expect to turn to 14 because at the end of the 3rd quarter, we were still in first place for exports. About 44 million of that came into North America. North America this year, ending 2022, I don't have the exact final number yet, but the last one that I saw was about 88 million. So we've had substantial growth in North America during the last calendar year. We have a certification program for engineers, installers, and designers. And I wanted to show this to the group today because this is something that we offer to our dealers and our partners and our clients. They are free of charge. They are 2 days in length, and we're currently doing them all around the United States. And so if you have technicians or staff members that are the type of people that would be servicing, installing LED product by any manufacturer, classes like this are available to you. And please reach out to me if you'd like to find out where and when the next course is near you.
Sure, yeah.
Okay, so we're going to talk about LED today. We all have seen changes in the display marketplace over the last several years. LCD, flat panels being made into walls, projection has been declining as a display medium. The introduction of laser-based projection has saved a significant amount of money in terms of having to re-lamp projectors every year. It's also helped the environment because we don't have to dispose of the mercury in those. And LED is being found in more and more places. We're seeing it in education. We're seeing it currently down even as low as into the K through 12 market space. We have several middle school projects that we recently have begun to work on that utilize some of the more entry-level product in the market space. Conference rooms, we've all seen them in airports. We know them in performance art spaces and theaters, things like that. The famous elevator lobbies that we see in buildings, particularly, I think Salesforce in San Francisco is probably the most famous with their waterfall effect. So LED was invented in the 60s. It was a monochromatic display. So much like if you remember CRT monitors originally being introduced, they were simply black and white. Now we moved on through projection technology of CRT and fluorescent tube by companies like Sony and Mitsubishi. And projection really reigned the video wall market at that time. Then in 1992, they invented the blue LED. So prior to the time of 1992, you had individual pixel sets that would be put out in single colors. So now we have what we call the RGB triad, since we've added what's known as true blue LED. And that gives us the ability to create an LED pixel set so we can create true color. Just 5 years after the invention of the RGB triad, we had the largest rock and roll band in the world toured with large displays. So that's a long way to come from the invention of the triad to the actual use of it in the market space. Now, these were very large pixels. They were very expensive walls. They were difficult to maintain, but that has all evolved since 1997 to where we are today. In the early 2000s, we had significant changes in the volume of sales of LED, and as volume of production increases, costs begin to come down. In the late 20s, or by the late 20s, I should say, we had significant decreases in the cost of the product, and so we began to see it used more and more in non-traditional spaces. In the 2010s, we moved away from the triad of RGB and where you had individual pixels, and we moved into what's known as the encapsulation world. And the invention of the SMD encapsulation module was really the first step in that. And I'll talk about these technologies a little bit later. Then in the late 2010s, IMD technology was developed. And here in the early 2020s, we have chip on board and micro LED technologies, which is really taking us to the next. So what is LED? It's a cabinet, much like an LCD flat panel. You can buy them in different sizes, generally in the commercial market space, which I'm going to focus on today. For institutions like colleges and universities, you see something like this. It's a 16:9 aspect ratio cabinet. It's generally anywhere in brightness from 600 to 1500 nits. For those of you who are used to using projectors, a nit is a form of brightness calculation for monitor displays. You can calculate out from a comparative purpose, you calculate a nit by lumen conversion by taking the lumens and dividing it by 3.426. And so, for example, 1,000 lumen projector would be 291 nits for comparison's sake. Pixel pitch on them tends to range from as small as 0.7, which we're seeing multiple manufacturers introduce right now, and up to a 3.8 millimeter size. Now, again, since I'm only going to focus on commercial displays today, that generally is where the commercial displays top out. You can get 10, 12, 20 millimeter, 30 millimeter pixel pitches for large outdoor displays, but that's not what we're going to focus on today. So what is pixel pitch? Simply put, it's the distance between two pixels. So it's the center of one pixel to the center of its next adjacent pixel. What does this mean? We'll talk more about it as we go through this presentation, but basically this is called an SMD technology panel. So every one of these squares that you see is an individual pixel set. So it's in a frame. The white area is the actual pixel itself. So as we get larger and larger in the pixel pitch, these frames get larger and larger, and the pixel inside the frame gets larger and larger. Same thing for if we get a smaller pixel pitch. Those frames get smaller and the pixel itself gets smaller. As we change pixel pitch, having a hard time saying that today for some reason, we change the density of the pixel pitch. So if we think about this cabinet, I can sell this cabinet in 5 different pixel pitches, but it's the same physical size. So if I change my pixel pitch, I change my density. So if you consider this display 16 feet by 9 feet, perfect aspect ratio. If I have a 1 millimeter pitch, you can see just from this round area how many pixels are in there, representing the same space. In a 5 millimeter pitch, you can see how many are in there. And then same with the 20 millimeter pitch. Resolution is directly impacted by pixel density. So in this particular display, we have a much higher resolution than we do in the other two. So let's just take that into a real world example. You have a professor coming into a space with a laptop that has a 1080p output, and I want to put it on a 5 millimeter pixel pitch. Well, I have more resolution in my signal from the laptop than I do in my wall. And so that means I need to have some sort of scaling where I squish down the 1080p signal to fit it into this resolution. Same thing exists with this display. If I have a 1080p signal, but I want to display it here, I have to scale it as well. But instead of squishing it, I expand it. So part of your thinking when you're trying to consider LED walls is what pixel pitch is right for viewing distance, but also what pixel pitch is correct for what you want to display. If you need a resolution without scaling, then you have to plan your design to meet your source resolution. So the cabinet design itself, cabinet's made up generally of 4 pieces. You have the cabinet itself, the frame. Frames are made of extruded aluminum. Sometimes they're made entirely of extruded aluminum. Sometimes they're made with molded plastic, and sometimes they're made with a combination of both. In this case, this particular cabinet is made with the extruded aluminum frame for rigidity, and then the molded plastic for the back cabinet. Then you have what's called modules. In this case, there are 4 modules for this particular cabinet. There's a connector in the middle of the module that plugs into the board that lives inside the cabinet, and then they're held on with magnets. It's that simple. Then you have power supplies, and you have what's called receiving cards. In this case, it's showing a redundant. So normally there would only be 1 power supply and 1 receiving card. And that way, a receiving card is where you plug in the cable that's coming from your wall controller that contains the signal for the cabinet to display. They're mounted generally using mounting brackets. There are very simple flat wall mat brackets. There are very complex ones. This case, this bracket is much like you would use to hang an LCD monitor, say in a digital signage application. You simply attach the cabinet to this mounting bracket rather than attaching an LCD monitor. Generally, the most popular way to do this is a single mount per cabinet. If you have a small wall, something smaller than maybe 8 cabinets by 8 cabinets. But this is a very popular way to do it, and it's the least expensive. There are also mounting systems available. This particular one is made by Draper. They're a good partner of ours. These mounting systems are based on a rail structure. So you have the horizontal rails that attach directly to your surface. You then have the vertical rails that you space along those horizontal rails to the proper width of the cabinet, so they can accommodate different size cabinets without having to re-engineer the mounting system. The cabinets are typically installed onto the rail system without the modules attached to the front. So they're packaged separately. So you simply bolt the cabinet onto the mounting system, apply the modules to it, and you're ready to move on and finish your installation. You can get these in flat wall versions. You can get them with curves and shapes and corners and all different things. The there are plenty of mounting system manufacturers out there that can do custom mounts as well. We see what we have hanging mounts as well. We see this type of application done in performance art spaces. Maybe it's in a theater department on campus, and they want to attach it to a theatrical batten so they can raise it up out of the way when it's not needed and maybe lower it down for a digital background. We also have freestanding structures that the industry, plenty of manufacturers make. The freestanding structures we tend to see when a space that had a rear projection room is being upgraded and they don't want to do the structural improvements to fill in the hole that was there when the rear projection screen was there. They simply build the freestanding structure to fill that gap, that hole. We also call this ground stacking, so you may hear that name occasionally as well. So pixel types, on the timeline, I mentioned SMD, IMD, COB. These are all different types. They have pluses and minuses, and we'll just run through them. So an SMD is a surface mounted device. You can see here, it is from the pixel pitch slide. I showed the square frame that the pixels live in. Then the pixel set, it's the chip set with the LED pixels attached to it, is put inside that frame. You then have the electrical is done by a gold wire that's done down to an electrostatic plate. And then you fill that frame with an epoxy. It's then attached to the PCB board, which is the board that makes up the module that I showed you earlier. So a couple of things about this. It's been around for a long time. It's the least expensive to manufacture. It's very easy to repair these when they get damaged. However, damage is very possible with these. Even incidental contact can cause damage because these bonding feet are exposed. They can easily, you can pick a module, you can pick a pixel off individually very easily. So you have to be careful about where you place SMD technology. As you move into the IMD technology, this was invented by taking the SMD encapsulation method and simply making it better. The idea here is we take 4 SMDs and we encapsulate it into a single 4-in-1 IMD chipset. You'll hear the phrase 4-in-1. This is what they're talking about. So we'll have our individual pixels, they're attached to the chip. The chip is attached to the substrate. Then we have more bonding feet when we do this. And so we have a more durable connection to the PCB board. So IMD technology is 2.5 times more durable than the SMD technology. And then when we encapsulate the pixels, instead of encapsulating them individually, we encapsulate them in a 2x2 configuration. So this becomes one piece. So that's another reason why it's more durable. We're not chipping individual ones off. Difficulty here in terms of limitations is we can't get the package small enough to get below 0.9 pixel pitch. It's something that just the limitations of the physical size of the technology stops us from being able to move forward. So now we have chip on board technology. This has come out here in the last couple of years. As the name implies, we're simply mounting the chip on the board. So if we look at our SMD technology, individual pixels that are mounted to the PCB substrate, now what we've done is we've taken this substrate layer off here and the bonding feet off, and we have moved the chip directly to the PCB board. We still have our wire bonding for power, but basically now what we do is we encapsulate the entire PCB board module in a single epoxy layer. And so now I can no longer chip off individual pixels. So I'm protected from physical damage, even beyond incidental contact. You don't have to worry about a basketball hitting it. You don't have to worry about somebody walking up and smacking on it, that sort of thing. You can also now with this, you can do touch overlays because now the surface is sufficiently strong that you don't have to worry about damaging it if it gets touched. Limitation here, cost. It is an expensive production technique, and then it's very difficult to service. If I have an individual pixel that gets damaged, I have to remove the epoxy substrate from the entire module, repair it, and then recoat it. So it's a much more laborious process. SMD and IMD products can be repaired very quickly, very easily in the United States. There are plenty of manufacturers who have service centers, including Absen here in the US. These generally have to go back to the factory to be repaired. So then moving up to the most advanced technology, flip chip on board. As chip on board implies, we simply mounted it directly to the chip. Flip chip says we flipped it over. So again, here's that traditional COB style. We attach it to the PCB board. Same thing with the bonding feed for electricity to the electrode. And then the chipset, the actual LED chips themselves are on this side. What we do here is we actually take that chip, remove some of those substrate layers, flip it upside down, attach it directly to the PCB board. So now I no longer have wires that have to come down. So I no longer have to plan for that gap because I would have another bonding foot and then the chip and then a bonding foot over here. So I'm creating gap here. So if you go flip chip on board, you basically don't have to have as much gap in between, so you can get an even smaller pixel pitch. This is how we're getting down into the 0.7. It's how we're getting down into the 0.5 pixel pitches that we're seeing being developed now. The other thing about the difference is on a traditional COB, typically the epoxy layer that's on top is reflective. So much like our LCD monitors are with black backgrounds, I can see myself reflected in my display. Flip chip technology tends to use matte surface epoxy layers, and that eliminates the possibility for the glare. Just for comparison purposes here, Absen sells SMD, IMD, normal COB, and flip chip COB products. This is our most popular COB product, and it is the matte surface, where some manufacturers have the glossy. Not that I expect you to read the whole chart, but I just wanted you to know there are differences physically in the technology. In some cases, if I have issues with moire effect here, I don't want to buy an SMD technology. I want to buy a COB technology. That sort of thing. So moire effect, I'll mention it here briefly, just so that you know what that is. If you've ever had a theatrical performance being shot on camera, or if you've ever been in your house of worship and your pastor's walked on stage in front of an LED display, you can see this sort of effect, this swirling effect on screen when the camera captures the LED screen. This is caused by the fact that those packaged pixels are squares, and the image sensor inside the camera that you're using has square sensors on its chip. And so when you scan across an LED screen, the square pixel package and the square sensor chip cause this effect. If you're using COB technology, because we don't have the individual pixel package anymore, I don't see the moire effect. So if you're ever planning a project where you're looking at using a camera in front of an LED screen, moire effect is something that you have to plan for in your design. Distance, viewing distance very easily calculated as a meter per millimeter. So if you are in a 1 millimeter pixel pitch environment and you need to consider what your minimum viewing distance is, it would simply be a meter away. And those numbers calculate off very easily as you go through the different pixel pitch options. Now that's not maximum viewing distance, that's minimum viewing distance. And we calculate that out as the closest you can be to the display without being able to differentiate individual pixels. Obviously, if I'm in a football stadium, I can be way out here in these pixel pitches and not have an issue. So what are the trends in LED right now? The biggest trend that we're seeing is what we call all-in-one solutions. They come in 110, 138, 165, 220-inch diagonal in a 16:9 aspect ratio. They include multiple inputs. They include wireless connectivity like a Barco Click Share or a immersive Solstice type product. So you can connect with screen share from your Apple devices or your Android devices or your laptops. They have speakers and audio built in. They have scaling built in. They have pretty much everything that you need for a plug and play LED solution already included. They're coming out now in 16:9 aspect ratios. They're coming out now in 21:9 aspect ratio and also 32:9 aspect ratio in order to accommodate the sort of teams, rooms, environments that we're seeing in corporate spaces. Whether or not that applies in the higher education space is another issue. The other thing we're seeing is what I call smaller, faster, brighter. I spent 10 years working for a projector, or 9 years working for a projector manufacturer. And this is how I started to talk about projectors. And so this is how I talk about LED. Smaller pixels are getting smaller. We're well below the 1 millimeter point now. That was a huge breakthrough for the business. As I said, 0.9 and 0.7 are common among many manufacturers. And I think that many manufacturers are shooting for the 0.5 millimeter target as well. They're faster, their refresh rates are higher. Generally, in a commercial application, you see refresh rates around 3840 hertz. But today, we're seeing the refresh rates get as high as 10,000 hertz. And we're seeing it in virtual studio productions and things like that, where those high scan rates are required in order to not see the scan lines in the film. Brighter as well. This is something where the increase in efficiency in the design of the chips, as we go from SMD to IMD to chip on board and flip chip on board, every one of those manufacturing techniques, those LED types, as you move through them, the efficiency increases. So from SMD to IMD, I increased efficiency. From IMD to chip on board, I increased efficiency. So what we're seeing now is the highest brightness per watt calculation. So we're seeing displays that may be exactly the same brightness as an older generation product, and it's 30 to 40% more efficient in its power consumption. Shapes, curves, corners, columns, these are all becoming extremely popular as people think outside the box. And the box is that rectilinear display that we're used to seeing in 16:9 aspect ratio. So there are products out there in the industry now that handle things like curved corners or ribbon shapes, both convex and concave shapes, columns and corners, things like that are becoming more and more popular in the LED world. So that said, pretty much that covers the presentation for me today. Questions?
Well, thank you very much, Fred. I am curious whether there are scientific applications for refresh rates as high as 10,000 hertz.
I'm sorry, I didn't hear the first part.
Oh, I'm curious if there are scientific applications, visualizations, that sort of thing, for which 10,000 hertz refresh rates are useful and even necessary.
There are. We're seeing it in data visualization environments, whether it be in 3D or in 2D. We're seeing them in the, as I said, the virtual reality studios. We're seeing them in the 3D modeling environments. And we're even seeing them in, oddly enough, in some rental staging applications where the image magnification is pretty intense. So because they're not purchasing the chip on board product for rental staging, they tend to purchase SMD product. And so that Moire effect comes into play. And the higher your refresh rate is, the less likely you are to have issues with that.
Mhm. Thank you.
Certainly.
Do you know of any cinemas that have made use of this technology?
Well, that's a very interesting question, because what we're seeing happening in the cinema space right now is the first hurdle that we had to overcome is that we had to make certain that we had the appropriate color gamut. Digital cinema space requires a color gamut standard of Rec 709. We have exceeded Rec 709 in several of our products, as have other manufacturers. So that was the first hurdle to get introduced into the cinema space. The second hurdle is primarily an audio-based issue. Most digital cinemas, if not all, have perforated screens. So they mount speakers for the center channels and the individual Atmos environments behind the screen surfaces. And you can't do that with an LED screen, obviously. What we found is that there are speaker manufacturers out there today that are manufacturing reflective technology speakers. The idea being that they take advantage of the reflective surface, acoustically reflective surface of the LED display, and they point the speakers at the LED display in the ceiling, from the ceiling, and then those speakers reflect off and provide a more true center channel experience for the audio side. And so that's something that we're waiting to see whether that is accepted in primarily the viewing room space, the personal, private, large home theater, that sort of thing. So I'm seeing a question here from Regina. What does the training provide? Make sure I see that correctly. We, as I mentioned, we actually have end users who come to our ACE training classes. They, we have, I just had a meeting with a school district here in Texas yesterday, where they want to have one of the people from their team trained up because they're going to put in their first LED space. And it's an overview, not only on installation, but calibration and certification of those walls. We also teach you about troubleshooting and the use of the wall controller. You can set up many different configurations on the LED wall, and we teach the attendees of the course of that as well. And so it's something that we recommend anyone who wants to know more, please sign up and attend. Cost $0. You only have to get to the course itself. Locations, we're doing them around the country. We had been doing them virtually during COVID, but when we started back up in person, we've been doing them in LA. But right now we are doing them around the country. The next one that I'm aware of off the top of my head is in Dallas. And that is, I think, the 8th and the 9th of March. I know there are some scheduled for Chicago, and I think there's one in Indianapolis on the calendar right now as well. In the Vegas area, no, not currently that I'm aware of, but I would think Vegas would be on the calendar at sometime this year, but I don't have that. I can provide that information, a schedule of those courses to the group.
Is there a sweet spot where a direct view LED wall is favorable over a regular flat screen display as far as size?
The primary reason that we see people still using LCD monitors for their walls is cost. We're not down to the point yet where we're providing exactly the same cost. We're getting closer and closer with our entry-level products. The sweet spot in terms of size is generally anything over about 110 inch. 110 inch would be a 2x2 55-inch LCD monitor display. Once we get larger than that, we're seeing more and more customers that are just not considering LCD at all, primarily because of the mullions that you see. And also with the reflective surface. And we have a lot of clients that come to us without a full understanding of what it means to have 4 monitors and how you have to split the source up so that it can be displayed over all 4 of those. And that's easily overcome with direct view because the way the wall controllers function.
Do you foresee e-ink hurting you guys at all? I know for a long time it's monochrome, but now BMW just at CES came out with some colored e-ink for their car.
Yeah, I don't, I see that in the near term as a novelty more than anything else. You know, I think that from what we have within the LCD business, LED business, sorry, is what we call the experiential design. And we have a lot of clients who they're more concerned about the environment that the client, that the attendee is in. How are they immersed in the space? What's their visual experience as they come in? It's not simply used as a tool to display a spreadsheet or a PowerPoint, for example. That's where I think that kind of technology will impact LED, but I do think that it's many years out before that happens.
The reflective surface phenomena is interesting. I hadn't thought about that before. And it's clever the way that the theater people are using a reflective loudspeaker. I wonder if any of the acoustic people have any criticism about what a direct view LED does to the acoustics when they walk into a room. I know one of my colleagues and I walked into a room in a research building here, and there was nothing in the room. It looked like a closet, and we just looked at each other and we were like, this is such a good room, because there were a couple of non-parallel walls and the right amount of fuzzy stuff. And I just wonder if the acoustic people have had any reaction to direct view LEDs.
Absolutely, they have. You know, it's just another surface to plan for. You know, if you consider a fabric-based projection screen, there is some absorption there, not much, but there's very little reflection. And so it's entirely different. My role within Absen is I work exclusively in the design, consultant, and architecture communities. So if you have a building being built, your architect has probably hired an AV consultant and an acoustical consultant. Those are my clients. I don't work with the dealer channel or the installers or anything like that. So I have a lot of conversations about the acoustics in the rooms with LED. But you're right. The other thing that with the cinema space is going to be a challenge is the handling the digital cinema signal itself, because you'd have to incorporate some sort of a digitizing tool in order to accept the signal and put it in the wall itself, because once you convert the file, it can't go down a cable pathway. So it has to be embedded.
So from a longevity service perspective, if you built a wall and with panels and you had your fibers out and a panel fails, as technology advanced, is that panel going to be able to be replaced and still right in the wall, or is that a whole wall replacement there? How do you anticipate life cycle on these longevity?
So the average in our product line, I can't speak to others, but the average life cycle in our product line is 100,000 hours to its half-life. And that's measured at 100% brightness and 100% full field white. So white is the brightest image, it's also, or color, it's also the what requires the most voltage to create, because I have all three our RGB pixel sets turned on. So 100,000 hour half-life at full brightness, I think it's 9.5 years. If you look at a typical LED display installation, something in an auditorium, for example, teaching classroom, most of those displays are run in the 50 to 60% brightness range. So if it's at 50%, it's doubling your 100,000 hours. From a service perspective, to answer that part of the question, the cabinets themselves don't fail. They're simply a physical frame. So once they are installed, they never have to move unless you're changing the whole wall. The power supply, receiving card that are inside the cabinet can fail and can be serviced from the front side or the rear side in all of our commercial application products. Many manufacturers are the same. Simply remove the modules off the front, repair the power supply, and or whatever has failed inside. From the module itself, say it takes a hit and it's damaged several pixels, you simply remove the module, place the new module in its spot, recalibrate the wall, and you're ready to go. Now, because the new module, which we and many manufacturers provide spares, we provide a 3% spare for every product. So you have a spare cabinet, a spare power supply, spare receiving card, and multiple spare modules for a wall. And what you won't do is, if you consider the fact, let's just say our wall's been on for 10,000 hours and I have a damaged module and I pull it off and I go to the closet and I get a spare one and I put it on the wall, that module has less burn time than the 10,000 hours the rest of the wall. And so we generally recommend that you pull a module from a corner that has the same burn time, put it in the spot where the damaged module was, put the new one in the bottom corner, and then recalibrate the wall so that if there is any difference in visual display because of the burn time, it's less noticeable because it's not in the middle of the screen. So if you're an IMD or an SMD technology, you simply box that up. You call the manufacturer, ship it to their RMA facility, they can repair it and send it back to you, and it becomes something you can either put back in the wall so that it has the same burn time, or you put it back on the shelf as a spare. So very easy to service and maintain. We actually have what we call a vacuum tool, which is a little handheld Dyson vacuum cleaner with a rectangular face on it, and you stick it up to the module, create suction, and pull the module off. So you don't even have to, pull off from the corner and work your way into where the damaged one is. You can remove any module one at a time.
Well, that's excellent, excellent. So this was a really great presentation. Do you have any more questions? If not, we thank you, Fred, for doing this. Joe, thank you for excellent marketing setting this up for us. I want to remind everybody in attendance that if you haven't signed up for our live event in Eau Claire at the end of March, if you're able to do so, love to see you there.
Great. Thank you again for inviting me. I really appreciate the time. And if you have any further questions, please feel free to reach out through the group to me. Thanks, and have a great day.
Excellent. All right. Thank you.
Thank you.